problem for doing these equilibrium calculations. And just like in the other problems, something different is going to happen here. So this is like three kind of different outcomes that we could expect, just really based on the algebra that we're doing. Okay, so let's get right into it. So gaseous NaCl decomposes. So I'm just going to get straight into this and set up my reaction. So gaseous NaCl decomposes. So that means it falls apart to form the gases NO and Cl2. And so now, of course, we need to balance that reaction. So I've got two chlorines on this side, so I need two on this side. Now that gives me 2N and 2O. So then now I can say 2NO on that side. Perfect. So there is my reaction, and we'll set up our little grid here. So now we need to get our initial concentrations. Okay, so now this says in an experiment in which 1.0 mole is placed in a 2.0 liter flask, so that's going to be 0.5 molar. And in this experiment, it says in an experiment, 1 mole of NaCl is placed in a 2 liter flask. Okay, great. So we have 0.50 molar of this initially, and there was no mention of NO or Cl2, so we'll assume those are 0. So that means getting our change column is going to be straightforward. So our products have to increase from 0, so they can't decrease from 0. So that has to be a plus X. Oops, let's see. Maybe you're like, wait, Harmon, that's got to be a plus 2X because there's a 2 right there. This one's got to be a plus X. And now this one has to be a minus 2X. Okay. And then finally, we can get our equilibrium column. So that's going to be 0.50 minus 2X. That's going to be 0 plus 2X, which is just 2X, and 0 plus X, which is just X. Okay. So now we set up our equilibrium expression. So that's 1.6 times 10 to the negative 5 equals. And so that's going to be products over reactants, and that's NO squared, because we got that 2 coefficient, times Cl2, all divided by NoCl squared. Okay? So now let's plug all this stuff in here. So we can say that's 1.6 times 10 to the minus 5 equals, and so that's going to be NO squared, so that's 2X all squared, times Cl2, which is just X. And then now that's divided by NoCl squared, 0.50 minus 2X all squared. Okay, so now we kind of have to stare at this for a minute. And if you think about this, okay, this 2X squared, that's going to give me 4X squared, times X, that's going to give me an X cubed. And that means we can't do it. We can't solve this just by hand because we're going to get an X to the third power. So I'll say that leads to 4X cubed. And we can't solve those types of problems by hand. We could certainly solve it with a computer program or with your graphing calculator even. But we're going to learn another trick here. And that trick is what we call the 5% rule. So I'm going to write that on this slide, 5% rule, okay? And how do we know, so what is the 5% rule and how do we know when to use it? Well, here's how we know when to use it. When we have a crazy small equilibrium constant, right? And 1.6 times 10 minus 5 is pretty crazy small. If we think about the other equilibrium constants that we've seen in the other problems, you know, one of them was 5.1. The other was like 115 or something like that. So this 1.6 times 10 minus 5 is really, really small. And so because it's so small, what that means is not very much of this NoCl is going to react, right? So go back to some of our very beginning slides. When K is much, much less than 1, we say the equilibrium position is on the left. And so that means at equilibrium, there's not going to be a whole lot of NO and Cl2 that is formed. Okay, so these values of X here are going to be really, really small. And that also means this 0.5 minus 2x, this minus 2x is also going to be really small. So we make an assumption here, which is the following. We're going to assume that 0.50 minus 2x is basically equal to just 0.50. Okay? So we're assuming that the value of x is so small compared to this number that we can ignore it. We can't ignore 2x for NO and nx for Cl2 because their initial concentrations are 0, and any number compared to 0 is significant. But what we want to do is make this easier to solve algebraically. And I can solve a 4x cubed by taking it to the 1/3 power. What I can't solve is when I go and FOIL this whole thing together. That's going to give me an x cubed plus an x squared plus an x plus a number. And that's what I can't solve by hand. Okay? And so this 5% rule says that we're assuming that 2x is less than 5% of 0.50. Okay? That's our 5% rule. That when we set up this equilibrium spot, if our change is less than 5% of the initial value, then we can ignore it. So now what that means is when we're going to solve this, 1.60 times 10 minus 5, so that's all going to equal 4x cubed. So I got that from saying 2x all squared, which becomes 4x squared times x gives me 4x cubed. But now this is just going to be divided by 0.50 squared, and this is really easy to solve, right? So to solve this, it's going to be 1.60 times 10 to the minus 5 times 0.50 squared, all divided by 4. And of course, that equals x to the 3rd power, right? But now, if I take this whole thing to the 1/3 power, and I take this whole thing to the 1/3 power, then I'll get my value of x. So let's do that. So that's going to be 0.5 squared times 1.6 E5 minus equals, and then divided by 4 equals, and then now I've got to take this to the 1/3 power. So I can do that on this calculator by saying this button 3 equals, and I get 0.01, and I'm confirming on my cheater notes that's the value of x. So x equals 0.01. Okay. So, but before we plug it back into these values to get our equilibrium concentrations, we have to test the 5% rule. Okay. So, and we test it by doing the following. Okay. We've got to say 2 times x, which is 0.01, divided by this initial concentration, 0.50. And if this number is less than 5%, then our assumption is good. So so we'll say times 2 equals 0.02, divided by 0.5, and that equals 0.004. And recall, that is the same thing as 4%, so our assumption checks out. Okay, and so now what that means is for my NOCl, okay, so I realize this is a bit confusing because we said assume that it's 0.5 minus 2x. We only did that to make the algebra easier. So we're still going to plug that 0.01 back into this 0.5 minus 2x, and we can check it again just to make sure that it works. So when I plug that 0.01 back into this expression, that's going to become 0.48 molar for NOCl. NO equals, let's see, 0.02 molar. And Cl2 is going to equal 0.01 molar. And these are our equilibrium concentrations. Of course, we can test it, and we'll test it by plugging everything back into here. So let's do that. So we're going to say NO squared, which is 0.02 squared. And then now that's times Cl2, which is 0.01. And then now we're going to say divided by NOCl squared. So that's divided by 0.48 squared equals, and look at that. I got 1, 2, 3, 4, 5. So it came out to be 1.7 times 10 to the minus 5, which again is close enough for this class. Okay. So once again, when we have problems like this where we have a very small equilibrium constant, and we're going to have to learn and get used to what a small equilibrium constant means, and we'll talk about that more in class. But when we see something has a really small equilibrium constant, we can use the 5% rule. The 5% rule is that we're going to assume the value of x is less than 5% compared to the initial concentration. And then when we solved for x and we tested that assumption, we see that it was less than 5%. So this assumption is valid. Okay.